this reality, which is the actual, everything that is what is a model and what is reality. And if there's really a versus here, models in the human sense become reality. So this recently, there's been a lot. Let me get a new layer here. When you look at a picture like colorized in some way, how the galaxy looks, if you want to think about it that way. That's a question I would ask myself. Is this really what it looks like? Probably say most definitively no. There's websites, content delivery now. Obviously the artists do crop on as well. In the sense, and I probably just have to get rid of this to make my point, which is draw some stupid pictures here. Which is if we've got some sort of satellite. This will be a really bad picture, but whatever. It's got some. These are light rays, right? And here's some stars out there. Stars or galaxies or whatever out there. Just objects out there. What's in here is some notion of physics put on little computer programs in here. There's instrumentation in here, and I'll just draw little telescopes. There's instrumentation that's going on in here. I have a couple of things that are going on. Color here. Let's go purpley. What's going on there? There is hardware, software, right? And all have assumptions built into them. And what I call physical limits. A simple way to think about it on a memory chip. Let's just draw one just so we have, for simplicity's sake. Let's say we only have 32 bits. We only have a certain limit, but we also, if I draw a little lens here, the lens itself also has a notion of information it can contain. There's some amount of discreteness in the actual lens itself, how sensitive it is in taking optical photons, light rays, whatever, how sensitive it is to information coming from these objects. And this picture is useful for us to picture because what's actually happening here, and I say this is like effectively infinity light years, meaning it's very far away, that there's a ton of stuff out there, whether it's vacuum space or whatever, massive objects, black holes that we can't see, other stars. There's effectively, and this is going to mess the picture up, but it's kind of useful to do that, which is there's this, what I would consider like field of noise, is actually lensing, if you want to think about it that way, messing with the information that's coming in. Let me get rid of some of that. So it's messing with that stuff. Now, what's attempting to be done in the physics that's in this big in space and then down on Earth, with all our little servers down here, is it's trying to account for some reasonable amount of this information distortion that's happening in here. Just like I said with these little instruments in here, all trying to interpret these things, where they have limits, there's a ton limit in terms of what we can know about what's actually incomplete view, if you want to think about it that way, or experience of whatever we're observing. No matter how good our instruments is, there's still some huge, infinite amount of information that we're missing effectively. Okay, so fine. Side of what I want to talk about here, and I'll just put it here, which is another layer. One, observation is limited. The instruments, the models, and our interpretation. So that's all the physics that we do. Okay, so that's just observation. Now, we have a second on these models. Models are used to do stuff. Or rather, humans and machines use models to interact. Okay, big, long, stupid sentence, important stuff. That let's deal with the human part later. But most definitely, my point about the observations is that humans, we know what we know, and then we put those models in our instrumentation, and the instruments themselves effectively have their own, quote, hardware models. So these machines are actively using these models to interact in reality. Okay, this all seems so dumb when you talk. It's actually an important thing going on here. Okay, so let's talk about a rover. Here's a rover. This is a really poorly drawn rover. There's its little eyes, ollie sort of. We shoot it out into space from Earth down here. We shoot it out into space. All these models to go and traverse the galaxy, and it lands on a planet. It then has some model of the universe, and yeah, we're communicating back to it and forth with our own models of communication here. It has limits in space-time, meaning it takes time to actually do stuff, but also bandwidth, like what kind of what level of fit what this rover is doing. So it's going around mining, digging holes in, let's say this is Mars, taking pictures out here. It's operating on incomplete. It's got an incomplete model of reality. In all of reality, but let's say it does lots of stuff. Okay, it digs lots of holes. It finds some water over here. Let's say one day, for whatever reason, years from now, the machine just falls off into space and it's defunct and it's dead and we can no longer communicate. We lose. Let me boost that a little bit. We lose, and let's say Earth can no longer communicate. Right, all this is gone. All this is gone, and there's just this planet with all these, and if this planet became effectively isolated from any of ours, and our rover's now gone. But let's say some alien spacecraft, and it arrives here at some point, and it sees these deformations they're working with, and it did all this stuff. Our models from Earth did material work, interacted, did work in reality. So now these aliens, this is a bad rendition of an alien because we know that they're not going to look like this, but what is the alien left to interpret? They're going to inevitably, if they're anything like the world and they're operating with their own models, they're going to come, and what will they actually be observing? What are they observing? When they come and see Mars increasing reality, a model, they have a model of how to interpret, and probably the way I would call it, they're now going to model of a model, etc., etc. A little bit strange. When we say that, and this is the dumbest, that big of a point, but in effect, models created a new reality, meaning a new physical reality was generated by these models. So in effect, for the aliens to have their model of a model, meaning their model interpreting what effect our model had on it, that's the only way that they're going to be able to get to any interpretation of actual reality. Okay? really kind of weird thing because come up with the statement that none of that all model, the old phrase, all models are useful, all models are wrong, but some are useful. Right? That's an old phrase. But the case I was making, a model can become reality. Okay. And let's use a simpler case, right? So, a simple program. And let's make it. I'm gonna divide it. This isn't the simplest I could do, but it's going to print a 1 every other second. Okay, and it will send that to a web page. Let's just imagine a browser. This is going to get a little bit. You got some, and it's just this thing that effectively would look like this. It'll print a 1, but also a new. You get a new line character. And this goes on. Now, what the question of this computer program? What's the model? Case is 1. I could just observe this pattern. Right? You'd probably notice that every second, if you refresh the page, there's a new one, and you would effectively to probably get back to this basic program. You may not know, right? Just observing this pattern, it may go on literally for longer than you have paid. Really know if that's ever going to terminate or do something else. And the browser itself is doing work out of memory. So we're back to the memory thing, meaning your web page will no longer. But the point is, there will come a point at which this no longer can do anything. Make other cases about what we mean by every other second and what's doing the timing of things. So you have all sorts of things that make modeling it. All I could come up with what this thing actually was would be the program itself. So literally code, and I'll just write the code. Timer, this will be a really stupid program. But just for people who aren't programmers, let's just say set timer if timer is, but just is 1 second past last second. So you literally can just keep a track of which second it is. Then print 1. Else, oops, do nothing. Okay? So this is your actual best model for that program. It is a description, this thing. But, the big but though, but this is where it gets the program. The program is not all of its behavior. Or rather, all that can be observed. From that program. Oops. Go. In the sense that the program, finite, if you want to think about this, finite description, finite model. But the behavior infinite output. Effectively, somebody could argue you'd have what can be observed. The only way that you observe this description is to observe it all. And you could say, here would be the counterpoint of whether I have if the program can be logically contained, the way I think about it is literally there's a proof, a finite description of a proof of that program. Meaning this program can only ever do this. This program will only ever do this, whatever this is, X behavior. Okay, now that for those that know this, we get into the world of halting problems and computability. And I don't want to get into all that technical stuff, math, but the point is, the question becomes if the proof or description is infinite, can you ever make a claim about its reality? And again, I'm not being super technical here. I'm saying and likewise, if the observations are infinite or unknowable, blah, blah. There's lots of different things I could say for more complex systems. Say, what can you say about reality? It's reality. So I don't want to get too confused. Okay, those are the essential questions. Okay, and so go back to our example where the rover goes off, little eyes, little motor, its little wheels, and it's got models, computer programs. And the difference, the big thing here I want to remind you is these aren't limited to observation. Meaning the rover does work. Model does work. Or model affects reality. If the model affects reality, it is part of reality. So if you want to get, okay, why I cared about thinking about this today is that Kripke's name, and I'll make a super thing, but I'm going to bring up an image. Here, I'm going to bring up this is, for a cellular, is Rule 10. These are very, if I have down here, like a grid like this, and this is step 1, and we've got 2. Think of each line as like the next step. I have these little program rule black thing. On the next step, you keep that cell black. Meaning, and there's 2 white. Actually just colored in according to these actual rules. Simple finite I used before, finite rule description, program description, rule set. We'll just call it rule set. Very simple rule. If I were to draw this all out, this goes on infinity. You're going to get all sorts of on how you set the initial to describe it here. But the point is, you can literally go on forever with this thing. Does Wolfram Alpha using here, because it has this rule, does it hit reality of Rule 110 and everything it will do? System. Is this enough if Wolfram Alpha has infinite memory? I would not consider 100% complete model unless it had all of the program, the result of these rules executed over time in model versus reality. Model, can the become reality? And what can we say about the model if it can become, which I think here you can make a case that keep executing this, and over time, Wolfram Alpha continues reality it has encoded in its the reality of this particular, at which the model is reality. Patience, to which I would say that is most definitely not true. That would be a very grave mistake, and I'll make a simple. You think? Let's just do a very simple example of time. This is time, and this is price. Let's say just a stock, and so you've got something going on, right? Prices are moving. There's lots of things happening in the market, and people are buying and selling stuff, and you have come up with some model of. Let me change the color. I'm getting locked into these colors. You have some model of base price is some function of time. You probably have some other factors. It doesn't matter. And you've got a reasonable model. Then your model, what you do with your model is you buy and sell based on that. So great. You're buying and selling. You're affecting these up and down movements with your actual model. This is actually, the models are going in and doing, they are doing the buying and selling, have come up with these models, and they go and they trade all these financial. Over time, that you came up with for this was never universal model. And you may say, well, that doesn't matter, except you've heard supply and demand, right? We have all these curves that these are what we call laws. And in physics, it's easier to talk about. Where this making is you can't really make a case for laws, certainly in this financial modeling. You took prices of a stock over time. You created a model. That model then went to become a buying agent. That model literally, it is now an agent. The model, an actor in reality, be modeling the model. Back to our alien example, we're modeling the model. So now this thing becomes weird. So if you go, let's just get rid of that. You go really far into let's just draw the time graph out here. Let's say that last graph was only t small, just a really small thing. And we maybe had this kind of model going on. And then as into the market, we could see crazy behaviors, right, that are doing all sorts of things. This is no longer a function, but you can't go back in time like that. But you're going to see a drift in what's happening as the modeling of the model starts to happen. Did you ever say anything about reality? And let's keep it simple. Pricing reality. Is we get to this point where the models are doing modeling, but it's actually what we were doing. And just like this aspect of the world, information is no longer available to from 1700s, 1800s. Kind of stuff. Yeah, you can limited by the memory, draw the memory chip again, of the technology of the time. So actually, when you're doing stuff, significant missing information about what came before that. And here we also have missing information, because this is today, there are so many models that understand some of the models and what they're doing. Today's neural network world, I'm drawing little diagrams of this to help me, where we have all these multi-layer models that become inscrutable to humans, frankly. You don't know what really is going on in those models, and when they're constantly modeling the models with incomplete data. Did you ever say anything? And the big question is, I'm not trying to say it's all relative and it's fake news. I'm trying to make the claim that it's all models. Reality is modeling. And there is no reality out of models modeling each other. Models modeling. And so it's anything. No, we can never stop modeling things. Understand models that were at play before, you got to have necessarily going back and reinterpreting reality, creating new realities, etc., for us to keep modeling. We can never escape. Have utility, communicate. We can usually point. We're not affecting reality and going to have to go back and remodel. So to me, a practical implication of this, modeling never stops. You can stop modeling, I suppose, but it doesn't mean the world is ever going to stop. In a sense, be humble, because you're going to keep modeling anyway, because things change. And things that we models are more useful the more models. I'm trying to think of a nice, simple way of saying this. The models are more useful the more models they encompass. If you want to think practically about that, one, that goes to Occam's razor, right? Which is have simple models that do lots of work. And I'm using that phrasing on purpose, meaning a good rocket space, however you want to think about it, rover model is one that can make it to and affect the most planets. That's a super simple layman's way of thinking about it. That a bad model is one in which the conditions of it being useful are so specific, meaning the model of the model of the model is so specific that it's hard to recreate or a slight change in some circumstance makes it hard to do. And it turns out there are other interesting implications if you want to think about it. So I'm going to draw a ring. Here's 17 miles of particle acceleration. Uh, 10,000 physicists on site or event, and this is the LHC, the Large Hadron Collider, and we're smashing particles together at very, very high speeds, speed of light. But we're doing singular collisions, and we have terabytes and terabytes of data, very specific physics to notice very small variations according to our theories. But the condition to use this apparatus and to interpret our models means we have to have a setup that is this extensive. And so in a sense, this model is not as useful as something simple like a Newtonian thing, force equals ma. The LHC does less work in the universe currently than Newtonian models of the universe, which is a weird implication. But in mathematics, we sort of know that mathematical branches like number theory, dealing with the actual, numbers that you know and love, 1, 2, 3, 4, 5, the counting numbers, negative numbers, etc., is often more, quote, useful than something crazy like proof theory. Or, I could go on and on about just different esoteric branches of math where they're interesting and they're logically cool and they're beautiful in a lot of ways, but they don't have a lot of applications. So in a sense, the utility, this is why I'm saying it's very important. I think this is important not to undercut reality, but to say reality is made up of more or less useful models. And the models that represent and allow different things to do work on each other effectively and robustly, meaning they're not perturbed easily, are the most useful models and, in fact, have the greater impact. Greater useful models have a greater impact. Impact in reality. And the big statement I'll conclude with is useful models are more of reality. That's it. Have a great day. Enjoy your Friday and your weekend. Bye.